let's interpret the model result. Well, one advantage is of the random forest is we can actually interpret result. So first, let's import modules, import tools for visualization. Import tools for visualization. Let's import tools for visualization. And then here from sklearn dot tree import, and then we import graph. Okay, export to graph visualization. Okay, and then import PyDot, and then import graph visualization. Okay, import graph visualization. And then let's pull out one tree from the forest. Let's pull out one tree from the forest. Let's pull out one tree from the forest. And then, so tree, one tree, which tree? RF, and then ST, estimators. And then fifth tree. Okay, fifth tree. And then export the image. Image to dot file. Dot file. To dot file. So dot data. Dot data is export graphics, and then we export a tree, and then out file none. Okay, because we want to see it. Out file none, or of course we can do like, if it is necessary, we can do like tree dot. It is up to you. Up to you. And then feature names, and then we can do feature names. So feature names, feature names is feature list, of course. Feature list. Okay. And then we want to round. Let's do the rounding. Let's do rounding. And then precision. Precision, let's say 1. Okay, dot data, it works fine. And then of course, because we don't have out file, so let's see file directly over here. So graph is feed, and then source, and then dot data, and then we want to see the graph, and then graph looks like this. So, well, it shows, well, this is such a big one. So yeah, it is maybe too big. The tree is so huge tree. So I don't wanna show you this entire thing. Okay. Anyway, in this way, we can see the tree. Well, such a large tree. It is not surprising because we have so many features. It is not surprising. So, well, let's take a look at the size of the tree. So print uh, size of the tree or the depth of the tree. The tree depth is the tree's depth is where tree's depth is where so maximum depth tree dot and then max depth okay, and the maximum depth is like 13. So we have like a 13 lengths of like 13 layers of tree. So it is like big. Again, not surprising because we have so many features. We included even unimportant features, right? So let's see the smaller tree. Trees for visualization. Smaller trees for visualization. So random forest, small. Let's define small random forest. And then random forest regressor, and then n estimator is, let's say, just 10. Let's say just 10. And the maximum depth is, let's say, just 3. So it is sufficiently very small tree. And then random state is, let's say, 42, same 42. Okay. And then again, we do the small, same thing. I have small fit. And then we fit train features to train labels. Okay, so we did fitting. So I want to require, so comma. And then let's extract again the tree. Tree is more equal. And then RF small. And then what? We extract again fifth one. So we extract small tree. And then again we do the same thing. Let's do the same thing. So dot data is same to export graph visual and the small tree small tree, and then our file none, and then feature names still feature names is feature list, and then rounded and precision, and then rounded true, and then precision 1. Such a long. Okay, dot. Well, it is long code, so it always happens. Out file. Okay, so our file is none. Yeah, out underbar file. And then it works, and then we can see the graph is actually we can directly see it grab feed, and then source dot data. Okay, so now we have sufficiently small tree. So we have only 3 layers of tree, right? Like this. So true, false, true, false. So we can interpret the result now. Okay. And then next, let's see the, now what can we see is the variables importance. Check the importance of variables. Let's check the importance of the variables. So importance is so basically we rf dot and then feature importance. We want to see the feature importances. So we have importances, and then feature importances. We will see. So I want to see the feature important. Let's print out importances first. So they are the importances where it is hard to understand because I don't have feature names. So I want to put feature names together. So how to do that? So feature importances is basically we want to zip. Basically we want to zip feature list and then importances, right? We want to basically do this and then this. Okay, so better, right? It is better, but so actually what I can do is and then print. How about this? Okay, much better. So it is important. So obvious importance of year is 0, year not varying. And then importance of those weekdays, they are quite small, as well as friend importance, and month is not so important. But most important one is actually the yesterday's weather. Yesterday's weather is uh, most important. Next important one is historical average. And third important factor is forecast by NOAA, and then other forecasting was. Others are basically not that important. Okay. Okay. So actually, there is another way of looking at this one. So instead of this one, instead of tabulate, let's zip it, and then zip it, and then importance. So create data like this one, and then we want to see the features and the importance. Features and then importance. We want the feature and importance. Feature and importance. For feature importance in this list. Okay, then Yeah, feature importance is, yeah, this is not yet pretty. Yeah, so then tabulate. Okay, they are same. And then actually I want to sort the things. Sort feature importances. Sort features by their importances. Okay, I want to do that. So feature importances is actually sorted. We want to sort one. Sort feature importances. Feature importances and by key. Key is we have to define lambda. Lambda is a very convenient functionality in Python. X1. And then we want to reverse. True. Okay, so reverse this. So, well, so year is unimportant. So most important is temp. Second one is like average, and then NOAA forecast, and then they are the important. And the days also matters. And then, yeah, 2 days ago temperature is not so important once we take into account yesterday's temperature, right? That's interesting. That's interesting. Actually, let's make a smarter. Let's make smart, smart printout. So print. Okay, let's do some smart printout. Variables, and then 20. And importance. And then importance is this one. But I want to do rounding format actually. This is something format by pair. Okay. Pair is not defined. Okay, that's fine. And then for pair in feature importances. Okay, so variable and importance like this one. Okay, actually, I want to do rounding where I should do round. Okay, there are so many. The decimals are too large, so okay, I can do the rounding over here. Round by 2, and then yes, much better. Okay, feature importance. Feature importance is 2. I'm not sure why we have this non-part. What is being printed out? Well, we have this one because, let me see. I'm not sure. Well, but, and then now we know what are the most important one. So let's pick just the 2 most important one. Okay, let's check the 2 most important one, and then I think we have more succinct model, and it may perform as good as the previous one. So let's do coding. And then what we can do is model with the two most important features. Let's model with the two important features. And then same RF most important one. And then random forest model. And then an estimator is 1000. And then random state 42. And then important indices. We know what are the most important indices. So we can seek feature list and then index. And then the most important one, temp one, right? That's the most important one. And then second one is average. Index and average. Okay, they are indices. And then let's train and test is train important. And then in feature, where we can see only important indices. Out of train features, we pick only important indices. Okay. And the test set is same. Test set is now instead of using every features out of test features, of course we select all data, but we use only important indices. Okay, important indices. And then let's train random forest model. And then we fit the model with what? With training model, train important to train labels. So we fit the model and then make it quiet, train, and then let's make a prediction. Predictions is most important, and we do predict, and then only important one, test important. We do the prediction, and then, well, we do the same thing. We calculate errors and accuracy, and then errors is first absolute value, and then, well, test labels minus predictions, their errors, and then we print mean absolute errors. Is the same as before, and then we can just errors and then print out. Yeah. So mean absolute error is like 4. Actually, well, it is very small. It is as small as the previous model that we use everything. So we can round by 2. So performance is, I think, very good. Even with the just the two most important figure is fine. So MAP is 100 minus, actually accuracy, M100 multiplied by 100 multiplied by errors, and then per test labels first, and then we have to average it. Yeah. And then accuracy is 100 minus MAP, and then we can do print. We can print accuracy. Accuracy is round accuracy 2, and then let's add percent. Okay, so almost 94%. So, well, it performs as good as the previous one, even with just two features. So 2 features is actually enough in this case. Okay, and then let's again do the visualization. Visualization. For visualization, well, so first list of like X locations for plotting, and then X values is okay. What am I doing? Length importance is that they are X value, and make a bar chart. Let's make a bar chart. So PLT now bar is, and then we use X values, and then we plot importances, okay? And then we have this beautiful bar chart. And then actually, well, orientation is, let's say, vertical. Let's vertical orientation. Yes, we have, well, it doesn't change much. And then let's put labels. I wanna put labels. Let's put tick labels for x-axis. So x-axis name is PLT x tick. X tick is basically x values. X values, and then feature list, tell the vehicle feature list, and then orientation is vertical. Orientation is vertical. PLT X ticks, no orientation. Well, X ticks, X value rotation. Orientation, no orientation is maybe just rotation. Okay, so we have this one, rotation. Okay. Anyway, we have a figure, and then let's put labels and title. Let's put and the title is Y label is importance. Yes, Y label is importance. Fine. And then I wanna put title. So PLT actually X labels. X label is basically variables. Okay, so we have a variable, and then title. Title is variable importances. Yeah, variable importance. We have title. So again, temperature 1, average, they are utmost important. They are good.